I make the world graphical.
I add value through my products.
I am an animator.
I am a filmmaker. I develop trends.
I transform designs to reality.
I create environments.
I translate stories to furniture.
I design experiences.
I'm an immersive media designer.
I design mobility.
This is not only a design institute.
This is a design lab.
Join us in our design movement.
I think we'll start with the session for today. I'll introduce myself. I'm Professor Amit Deshmukh. Along with me, we have Professor Bhavya Gupta, who's also here. And we will just try to ensure that it will be a very exciting 1.5 hours that we'll have. The sequence of operations will be that we'll talk about one topic, KISSA KURSI ka, which we have thought in that way. And after that, we'll make something. So this is not just a typical webinar where we are just listening and it's just receptive, but we'll parallelly make certain things with along with the work. And at the end, there will be question answer sessions that will follow. So yeah, I'll share my screen. Just a moment. So to start with, what defines a chair? Is it anything that you can sit on? Or the chair is considered as a very complex design process. It is also the most exciting of all. So designing chair looks a very kind of a simple job, but it is not. So industrial design is based on solid foundation of scientific understandings. And many designers, architects have expressed their design philosophies through design of a chair. So you'll see lots of architects who have, as an expression of their philosophies, designed chairs and which are very iconic chairs to say with. A chair design puts you at test at every aspect in design. So the design learning aspirant, why am I attempting this? So if we are very specific, say giving examples of chair, why should we go through this workshop? The workshop is aimed for design aspirants, giving them opportunity to develop their portfolio, enhance creative thinking skills, give an idea of design discipline in greater depth, and a glimpse of the process that goes behind designing a project. So we'll also have an attempt to understand the engineering aspect of design process. So a common tussle that happens, whether design is art or engineering in that way. So here, this workshop specifically is kind of accessed towards how does the engineering aspect of the entire domain kind of dominates the industrial design domain in that say. So we just keep debating, okay, art, design, but how does it happen in practice? So we'll demonstrate that through this workshop. So what will this design sensitization workshop will cover? So what makes design a science and not an art? So that is the primary focus. How to make quick conceptual models. So we'll make those actually. How to present your design and write about it. So at the end of the workshop, whatever you submit, we'll cover that. How to conceptualize and visualize a design idea. So definitely there will be lots of scratching of brain that is going to happen. How to consider a functional parameters of a chair design. And how to extract a context from a user through a mini questionnaire. Okay. So to start with, we'll start with the very basic question. Okay, what is a chair? Is chair something that we see typically in these images? Are these what we define as chair, or this is what will be defined as a chair? Or something like this, which doesn't look like a typical chair, but yes, definitely it's a chair. So again, what defines a chair? Is it the chair as a whole, or is it its parts? So does the chair design concentrates onto the separate components that it has, or the entire chair as a whole, or the space where it is placed. So a chair placed into this kind of a lavish living room would be different than something there in a cafe, than something there in a outdoor kind of a space, than something there in a conference room where the function of the space also defined in separate way. And that is where the discipline of interior space and furniture design kind of concentrates not only on furniture but also on interior spaces, and it looks at it in a very holistic kind of a way. Or the chair is defined by the person who sits on it, or who, for whom the chair is. So for example, if it is for a politician, does the chair expresses something else? If it's for a police person, does it has to show certain authority? If it's for a very ordinary worker, does it has to show something else? So all these questions is what definitely we have to look when we are looking through a design process towards a chair. Now, does a chair demonstrate a science? So as I said, that's the main axis that we'll be looking at. So what kind of science, what would be the science into the chair? And how does chair actually function as an object? So what is the function of a chair? To sit on it. So how would it function as an object? So either it fails, where the chair has broken down due to some reasons, or there is somebody who is able to sit on a very different kind of a configuration of a chair. So it's a successful product. Okay. So chair definitely is a functional product where a human uses it for sitting. Okay. So that's what it goes to. And what factors will make chair fail as a product? So how does it fail? How does it fail? So is it the amount of load that comes onto the chair? Or is it the way we sit onto it? Okay. Or is it the configuration of the chair? So maybe the configuration of the chair, that means how the legs, how the seat, and how the entire profile, what is the seating height, all these things are kind of experimented onto, and maybe that makes the chair fail. Okay. So again, these are the three factors that typically we look at: load, the way we sit, the configuration of the chair. Balance of chair, very, very important. You must have experienced this in your school days or somewhere, sometime, when you're kind of moving onto a chair and suddenly the chair leans too much backward and you fall down. Okay. So how does that happen? So definitely this word, center of gravity, is something that you have heard within your school days, and that matters a lot. Okay. So the moment the center of gravity moves beyond a certain point, that chair will topple. Okay. So that center of the gravity also depends on the way typically we sit. So all these scientific factors is what we are talking about. So a chair designer has to take into consideration these aspects, and these are very, very important for a chair as a product to work properly. So center of gravity, just to give you a glimpse, is considered at two different levels, and this is how it works. And also the load which comes onto it, any chair or any kind of a system, gets translated through the legs to the ground. Now this becomes a very important aspect, because this decides whether, at what point and how the chair will fail and how the chair will kind of pass. Now these are the load distribution analysis which a furniture designer, using lots of CAD softwares or kind of softwares and interfaces, analyzes before the chair goes for production. Okay, so maybe the red areas are showing where the chair would typically fail under certain loads. What changes he has to make so that the chair becomes a proper design. Okay. And definitely the sitting postures. So we, being humans, we kind of adjust onto chair at different levels. So even if a chair is designed for sitting in a particular way, we don't sit it onto it in that way. So that's how things keep varying and all these variable factors. Just try to imagine the load, the kind of the center of gravity, the way the materials have joined, the way people sit, the configuration of the chair, the heights at that whatever point the person sits onto it. If you can see that at certain point, a person is sitting at a very lower level, whereas in certain chairs he sits at a higher level. Okay, so all these factors is what make a chair design more scientific than just an expression of art. Oops. I think we talked about too complex things right now. So let's just simplify it and let's just try it out. So definitely we are not going to talk about all the complex facts that we just discussed, because those are the ones which kind of you learn when you're doing furniture design. Okay, but we just wanted to give you a glimpse of the things that, okay, what makes a chair design not very simple, but quite a complex activity in that way. So we often read stories about struggle and power in present as well as in history, and a chair is what the struggle is for. So that's why we call it KISSA KURSI ka. Okay. So chair thus becomes an emblem of authority, power, and stability. Now, does this contradict stability? Okay, does this image that we talked about stability over here, and the moment we say chair and stability, we have certain things in our mind. And does this idea kind of contradict stability? The moment you look at this chair, you feel that, if you sit on this, definitely it's not a very comfortable sit to put on. But yeah, definitely it's a functional chair. So with stability as a goal, how does designer design a chair? Okay, that's what kind of we'll have simplified, and we are going to look at it in that way. So can we take a glimpse of it? Yes, surely. Let's try it out. Okay, so we have to understand the difference between strength versus stability. Okay, and refer back to the template that has been sent to you. So all the people who have registered earlier, we have sent the template over there. Otherwise, I think we have attached it into the chat. You can download it from there and you can just take a print of it and just follow the instructions that we will kind of go through into this thing. Okay. So we'll try to make a chair, okay, and make it stable and carry certain amount of load. Okay, so that's what we are going to do into this workshop, and the material that we are going to handle with is paper. So I will hand it over to Bhavya sir. Okay, Bhavya will take you through the further journey, and I think we have the kind of setup over here. We have actual tools over here, and we'll just try out things in that way. Over to you, Bhavya.
Thank you, Professor Amit. So as you have gone through the presentation, we already know that there are multiple aspects that needs to be considered while designing a chair. It's not just the expression part of it or the looks of the chair, but it's the all science behind it as the person is going to sit on it. So just before starting, I'll give you a little brief about what tools we need to use and how we can use the template. So it's preferable you use a cutting mat over here, as you can see, and use a steel scale along with a paper cutter, and you can use a scalpel if you want to make very clean cuts and maybe create creases on the paper. So these 3-4 are the basic tools that we need to use. If you'll see the template, so let's start off with this particular template. There are 3 different designs that we have put in over there. Basic chair templates that we'll try to analyze in paper as a material, which is a very flexible material, and we think that it won't be able to take any load at any point of time, right? So just by folding it and applying few techniques to this particular paper sheet, we'll try to create a furniture model out of it and put some load and analyze the form of it. So let's start with this one, the third one, which is there. You can use scale and paper cutter to cut these. Solid lines needs to be cut, and the dotted ones are the ones where we create folds and give a crease to the paper to create the pattern. right? If you have not taken out the printout of template, there are dimensions and you can quickly draw it on any A4 sheet. Preferably, you should use 250 GSM or 300 GSM card sheet. If it is not available, you can use any of the old wedding cards also. That also works well for this particular exercise. So if you'll cut this first model, I have this pre-cut model, right? So this is the model that we have. You can use scale, and for creasing part, you can use the backside of the scale and just run the blade over those dotted lines, and that will give you a very clean crease. So you don't need to actually fold it by hand. You can just give a slight crease on it and then fold it over it. So you can see how smoothly and neatly you can fold it, right? Same goes for the backrest. So just fold these two backrest supports also, and you have to fold it the other way around, right? So this goes down and this you need to fold it up. Just apply 2 drops of Fevicol on these 2 points and it can fix it over like this, right? So if I'll show you the fixed model, it looks somewhat like this, right? Pretty much stable to see. And you can see that it looks pretty much like all the chairs that we see around. But can it take load and can it actually balance a human body around it? So let's try putting some weight on it, right? So as soon as I put weight on it, you can see that it starts to deform and it will basically break apart, right? And even if it's a person, he or she will fall. So what's going wrong in this particular thing? What's the problem in this particular structure? Let's give it a thought while trying to do the other one. So let's pick this one, the second one in the template that we have, right? So we'll cut out these 2 side elements out of this and 2 of these rectangular shapes out of the paper. These circles are not required for this particular model that we are making. So these 4 parts can be put together. Now if we'll see the other model, so here we have 2 frames. So it's 1 frame. It's different from the previous one in a way that it is not folding from one part. It is different parts that we are attaching together. And it's a single frame that we have taken for both the side supports, right? Now if we'll try to put weight on it, we can say it works better than the previous one, right? It is taking load pretty well. So it's not deforming on this axis, but what's happening, it's the lateral movement that is happening in it. So what we can see is somewhere these 2 legs are connected together, how we have created this side frame on both the sides. So what's happening is it's not all the legs that are going apart from each other. It's going in 2 ways where we have 2 side frames of the chair with us. So if we'll put load on this, it tends to fall laterally, right? Now let's try a third one. So third one is this particular template, which you can cut it out. And once you'll cut, it will look somewhat like this. You can fold these from the side, take it down, and then stick this together with a Fevicol, right? Once you will fix this, it looks somewhat like this. But what we'll do is the legs that we have created are attached separately, and it's not the straight paper that we are actually using for creating the legs. So what we'll try to do is take a sheet of paper, take this width as 40 mm, since we are making 1:10 scales of furniture model. So let's keep the standard height of chair, that is 400 mm. So in 1:10 scale, we'll keep it 40 mm, right? So you can keep this 40 mm and then same scoring we'll do. So at every 5 mm, you can draw lines and then do scoring, which is creating creases with paper cutter, right? Once I'll do this, I can start folding this. 1 up, 1 down, 1 up, 1 down, right? So you will see this kind of structure being made, right? Now, once this is complete, now if you'll see, this takes load pretty good in this particular direction, right? While if we'll put it this way and put load on top of it, it tends to fold. It will get flexible, right? So we can see that how paper can support load when we do these different creases and fold the paper together. And that's how you can make 2 of such creases out of this, right? And then fix it onto that particular chair, right? So if you'll try to make this, it takes the load pretty nicely, and it's very much stable. There's no lateral movement that is happening. There's no even deformation happening to the form of the chair or structure, right? So if we'll see what's happening is there are multiple folds in the paper that are being placed, right? And these folds act together, and it's difficult to move them around, and it takes the strength. So that is where we can see how there's stability and strength in this particular structure that we have, right? Similarly, if we'll try few other models for this particular kind of chair that we have. So you can cut strips of 5 mm wide and try making a structure out of it in this particular way, right? So if you'll see this particular structure, this is fairly good. I haven't included any of the seat on top of it. Maybe you can use the previous seat that we have over here, and that can be mounted on top of this structure to see how the load is getting transferred and it is taking the load or not. But what's happening over it is we have 2 frames. So if you'll see, we have two frames over here, right? One is this, and the another one is placed perpendicularly on top of this. And we have a connecting member at the bottom. So what's happening is they all are connected together. Somewhere it is a very close structure that is forming. With respect to this, the first one that we have made, you can see what's happening over here is these 2 legs are connected together, but there is no connection happening at other places. So when we are putting load on it, it tends to deform, right? While in this, we have connected these together at a right angle, and these all are working as a whole consolidated structure, which can actually take the load, right?
Okay.
Maybe we can try another one also, or I would like if you can try at least making 1 or 2 of these, and we can discuss how it is happening at this point of time, right? So I'll just go through it again. Once again, you can cut out this particular shape out of the template that we have. These are the folding lines at 6 points that needs to be folded, right? And then you can fold these by using the back side of the paper cutter, and then take this up and stick it at a point so that you receive, and finally you get this particular structure. Then try testing its structure by putting a load on it and see how it behaves, how it splits apart in this particular axis, and it gets flattened as soon as we put the load on top. Same goes for the second one. Again, I'll mention that we have taken one side frame all together. That means 2 legs are connected together along with the backrest on both the sides, and we have placed a backrest and a seat on top of it. So as soon as we put load on it, it tends to basically move laterally. So there is a very much horizontal movement that's happening. And if we'll analyze, then it's happening because these legs are not behaving together. So it is behaving as if 2 frames have been put side by side, and there's just a sitting surface on top of it. So it tends to move laterally, right? And as soon as we applied few techniques on the paper and tried folding it for a longer span, we saw that it tends to take load pretty much nicely from the top, right? But if we'll see the same structure from this side, it is very much flexible and it doesn't support any kind of load. So that's something that we can understand through this particular model that we have, right? Again, we can see that how it is very much taking the load, but again, you can see that these two legs are behaving separately. It's just the strength of the force that are being given over here that this particular structure is pretty much stable, right? Same goes with this, where we discussed that we have placed two perpendicular members together along with a connection at the bottom part. So it is not only connected at the top, but there is also a connection at the bottom, and how this particular structure works in a sync and as a whole. And these components are not acting as separate components as we saw in the previous ones, right? Now there is another technique that we can use for making a structure apart from folding or creasing. So let's try, take a strip of paper, again 40 mm in height, considering the 1:10 scale. Take one of the rods or a bamboo stick or any wire which you have at home and start rolling it out from the corner, right? As soon as we start rolling it, you will start feeling that it is creating a cylindrical structure which is very much stiff and stable. So even if I'll stop in between and see, so you can see it is very much stiff, and it takes any kind of stresses from the side onto this particular structure, right? So you can create these kind of rolled paper forms for creating structure. Just apply Fevicol at the end point, and then you can cut these for creating the structure. So similar to this one, let's try with 3 legs out. So we have paper rolled and placed together in this 3-legged structure that we have. And again, we have connected it from all the sides. And there is a place on top where all these 3 legs are connected, and we can mount a seat on top of it, right? So if we'll see this particular structure also, same principle, even in 3-legged structure, it pretty much takes the load. There is stability. Even if I'll keep something on top of it, it will definitely take the load of that particular object, as in these two, right? So one of the aspect that we are trying to very much focus on in this particular exercise, it's not we are trying to do everything in this particular exercise that we are trying with models, but what we are trying to see how a structure works together in chair, and how each component should be connected to each other so that it works as a one structure, and there are no breakages or movements happening around, like we can see in this one. So that is the major understanding, and one of the small things that is very much important when it comes to chair designing, as we have seen all throughout the presentation also, that there are multiple things to be taken care of: user, feel, look, making of it, material, structure. And out of these many things, this is one of the small things that we are trying to look at through this workshop, and trying to give a thought that how a structure of a chair should be made, which should support a human load, right? I hope you have followed this pretty much well. And what we would like to do is, the first structure that we have made, this particular one with a bent folded paper, what we would like is you to think on it and try to make it more stable and give it a strength that it takes a small amount of load, as I was trying along with the workshop, to try putting Fevicol or try putting load with my finger and see how the parts are moving together and are they stable or not to take the load. So similarly, what we would like, if you can actually think on this particular structure, play around with it, what things can be added or subtracted from this particular structure to make it more stable and make it ready to take load together, right?
Yeah.
Yeah.
So it was very quick understanding of basically the scientific aspects of about the chair. Okay, but as again Bhave rightly explained, a simple material like paper, okay, and we feel that it won't be able to take any kind of load. So the challenge over here is we are working with this as a material and try to make this stable. So we have lots of kind of preconceived ideas in our mind that paper is very fragile, paper will not take the load, but it doesn't work that way. So definitely there are exercises which you must have gone through in different kind of assignments also, that how to make structures out of paper, and some amazing work that people also have done in this. Now, apart from the material as a part, okay, when this kind of blows up into the real scale, each and every material differs. So these kind of complexities is what it's not about designing a pretty shape and giving it yahan pe, so whether the decoration has to be given on this side, the decoration, it's not only that. Definitely the form of the chair matters a lot. And I think I'll just share my presentation again and we'll show you some extreme examples that are there. Okay. So just going back to the presentation. So with these inputs that we talked about, can we arrive at a conclusion? Okay. So let's see some extreme chairs that we kind of quickly have collected. And you'll see these kind of extreme expressions. So a very crooked form which can still take a human load and which can be used as a sitting surface. Okay, every time we think of chair with 4 legs or in that way. So just a kind of expression or a design with 1 leg still can serve the purpose of sitting. This is exactly not sitting, but it's perching in a way, but yeah, definitely it's relaxing for a while. Chair with 2 legs, chair with 3 legs without the surface. Okay. Now, every time the expression, the functionality, all these things are debatable. Okay. But every chair has a context and the chair is designed to suit that context. Now, taking that into account with that kind of a form expression that it has, every chair has to be stable. Okay. And that is the scientific aspect that we talked initially and what we said that we will be coming up or will be kind of demonstrating into that. And I hope we have kind of looked at it in that way. You can see this chair also at the corner, which just has 2 legs, and one can immediately think if one sits on it, definitely he will topple, but that doesn't happen. So considering the center of gravity and all those aspects, the chair is stable in many ways. So finally, a chair is an expression, but with science in it. So if as an expression, I kind of look at these different forms, I put it together. So it has 3 legs, it has a sitting surface with a bulge onto it. This works as a handrest. Yeah, definitely. This is something that we consider as a chair. But again, to functionally make it work, it has to follow all the scientific things that we talked about. Now, what we expect you to do is, as Bhave sir explained properly, so just experiment with the kind of templates that we are given. Okay, so what can be done to make this chair stable? Okay, so we just explained you few techniques, 2 or 3 techniques that we are. So this is where you have to put your creative minds and you have to think and you have to make this chair functionally stable. Now, what is the limit? So what kind of load should I put onto it? Just think about it. Again, we are not defining that it has to take certain amount of load because it will depend on the thickness of this paper. If you have used a cardboard, if you have used a kind of wedding card and that kind of a thick material, it will bear more weight. Okay, but it should not open up the way that it was opening up. That is what at least should be achieved. Try with it. Take a photograph, click a photograph with load. Okay, and there's a Google form link that has been attached into the chat. Okay, and whatever your photographs, whatever your experimentation is, just make a very one-page PDF out of it and send your chair images in the Google link that is attached in the chat. So what we kind of are looking at is, it could be in just one A4 kind of a format. And these are the experiments that we've done. And what we are looking at it is, we will collect all the entries and will announce first 5 winners. Okay, so whatever we think that, okay, people have thought about it, the learners have thought about it, the students have thought about it and have come up with a very interesting kind of a solution, we'll rate them. We are going to put it as a competition. We are going to rate it as entry number 1, 2, 3, 4, and 5. And those entries with the photograph of the person will be published onto our website within few weeks. Okay, so these entries has to be submitted by tomorrow. The link will be open till that time. Okay, just fill up the Google form and submit the entries to that particular link. And out of those entries, definitely we'll evaluate. We'll see how extreme you have gone, and we'll announce the winners in that way. Now, again, just to recap what all we have looked at in that way. So what makes design a science and not an art? I think we definitely looked at it, looking at certain scientific aspects into it and seeing how those parameters govern the design process in certain way. We did make certain conceptual models. We did thought about how to present your design, write about it. So that's what you're going to do with those kind of expressions. You will kind of club things together and you will put it together and write about it in that way. The conceptualization process is important, definitely. And you need also to visualize and analyze what is happening and where the chair is failing. Okay, so very simple kind of interventions also can make this chair look or stand or take certain amount of loads in that way. And with the kind of those questionnaires in mind, we have looked at the context from the user. So the context over here is getting stability to the chair. So through these, what can happen is what we have looked at through it as a mini questionnaire in that. So yes, as I said, the 5 entries is what we will definitely like to look at. And I think, yeah, that's all what we have from here, from our side over here.
I make the world graphical.
I add value through my products.
I am an animator.
I am a filmmaker. I develop trends.
I transform designs to reality.
I create environments.
I translate stories to furniture.
I design experiences.
I'm an immersive media designer.
I design mobility.
This is not only a design institute.
This is a design lab.
Join us in our design